one of the simplest things you can ever do in a chemistry class to make your life easier is to figure out a way to make it easy on yourself to figure out where the metals are and where the nonmetals are, and then pretty much just kind of have access to a periodic table that has some kind of a label that lets you figure that out. Now, I'm actually going to go through many of the major groups on the periodic table, and if you actually haven't done any of the labels on your periodic table, or for some odd reason you have a blank one or whatever, it doesn't really matter. I would highly recommend that as you're running through this video, you pause after I say where a group is located, and then you make sure that your table has that label in particular. Really, the whole point of this video is just to kind of tell you, okay, here's how you can figure out what the metals are, and here's how you can figure out where the non-metals are. But I'm going to take this as an opportunity to take it a little bit of a step further so that you really understand why we call certain things what we do. And we have the labels there, but really what I'm just going to be doing is I'm just going to be kind of circling based on what we have. So look, metal versus non-metal is really, really straightforward because you essentially have 7 elements that you can use to create a boundary line that you, if you remember where they're at, you know exactly who's going to be a metal and who isn't going to be a non-metal. Now, the reason why you need to understand this is because there are shortcuts that you can take that if you understand the behaviors of metals and if you understand the behaviors of nonmetals, you actually understand a lot about bonding. And bonding is one of those things that is essentially central to what chemistry is. First things first, on a periodic table, and it's already kind of shown here, but boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, the guys that I'm going on right now, hopefully you can see this, those 7, those are your metalloids. Just that, or semimetals, whatever you want to call them. It's pretty much like the 7 elements that are in between being a metal and being a non-metal. They're your metalloids. Now, the reason why this is really, really useful is because it's honestly this simple. All of the elements to the right of those nonmetals, so like that, those are called the nonmetals. And so this is why it's very, very simple for you, where if you just kind of show where the metalloids are at, you can keep it that simple for yourself. All of the elements to the right of the metalloid ladder, because they do call it a ladder because it does kind of look like a stair step if you kind of look at it. I mean, like this whole thing right here almost looks like you can kind of treat it like stairs. That's why they call it a ladder. Regardless, it doesn't really matter. That's just a digression. Keep it that simple. All of the elements to the right side of the metalloids are nonmetals, and then it's really that simple. All of the elements to the left of that, so let me see if I can actually get around it. So around aluminum, you take all of your transition metals, you take all of your alkaline earth metals. You don't actually count hydrogen. I don't know why I did that. You do not count hydrogen. Can't believe I just did that. But hydrogen actually isn't one of them, and I'm going to talk about why. But pretty much, once you're there and you kind of have lithium, francium, you actually do include the lanthanides and the actinides because they do count as metals. But essentially, that's what I'm trying to say. Like, look, you keep it that simple. All of the elements that are to the left of the metalloid ladder, you consider metals. And again, if you look at the periodic table, you realize that odds are, if you're talking about an element, it's probably going to be a metal. But you need to keep it that simple. Look at the metalloid ladder, use it as your anchor, and then just kind of go left and right and just base it off of that. But again, just to kind of preview the groups very, very quickly. The alkali metals are essentially group 1A, not counting hydrogen, because hydrogen is a non-metal. It's not actually a metal. And so what that means then is that if you focus on what the alkali metals are, it's these guys right here, group 1. So lithium, sodium, potassium, rubidium, cesium, francium, so on and so forth. When you look to the right of them, these are the alkaline earth metals. You see that gigantic block in the middle? Those are called your transition metals. Not counting the guys at the bottom, although if you look at the guys at the bottom, they kind of tell you what it is. So the lanthanides, and then the actinides, and so on and so forth. So these would be the lanthanides, these would be the actinides. And then this next section, which are called the poor metals. So these guys, they're still metals. It's just that they so happen to be called poor metals because they're very close to the metalloid ladder. To the right again of the metalloid ladder, you have what are essentially all of your nonmetals, and yes, that does include the noble gases, and yes, that does include the halogens, because again, the last group, don't forget the last group. So these guys are your halogens, or sorry, those guys are your noble gases. I should not have said halogens. I was thinking about group 17. Group 18 or group 8A are your noble gases, and then group 17, they're pretty special. We like to call them the halogens. And it's really that simple. But again, if you're thinking about metal or non-metal, just make sure that you focus on that metalloid ladder and you look to the left for the metals, you look to the right for the non-metals. Keep it that simple. And that's it.